Area under the curve. In core 1 we carried out integration, but we didn't really give it any reason or any purpose for doing it. Well, in core 2 we actually introduced that reason why we might want to carry out integration, which is to find the area under a curve. So here we've got the curve y equals x squared plus 4. And we're asked to find the area between 1 and 3. Now you can see that it roughly makes a trapezium. If you follow the shape, it roughly makes a trapezium. However, if we were to just find the area of that trapezium, which would be quite easy, because we could easily find out that height, and we know that distance, it won't quite give us the exact answer. It would give us a little bit of an overestimate because there's this gap here. So, to find the area of a curve, what we do is we actually integrate our curve and then we sub in what are called limits. So as we're looking to find the area between 3 and 1, we sub in the limits 3 and 1. And that will give us the area of the curve when we work through that. So let's just try this example. So the first thing we're going to do is to integrate with respect to x between 3 and 1. Now you'll notice that I wrote the larger number at the top and the smaller number at the bottom. That is always the case. So when we're finding the area using integration, we're finding the area under the curve. Now in a later video you'll see the problem when we look at graphs to do with minus x squared. So integration, remember to integrate, you add 1 to the power and divide by the new power. So the x squared becomes a cube divided by the 3 plus 4x plus our constant, and we put brackets, and we put our two limits, which are 3 and 1. Next, if we integrate this now, if we substitute in our two values, so we've got 3 cubed divided by 3 plus 4 lots of 3 plus the c, that's the first one. And to find the area, this is the thing you must remember, is we're going to subtract the other one away. So we're going to subtract when we substitute 1 in. So 1 cubed minus 3 plus 4 times 1 plus our c. And close brackets now. I don't know why I put those brackets in here, but have. If we sort this out a little bit, the first bit is 3 cubed is 27 divided by 3 is 9, plus 4 times 3, which is 12, plus the constant. 1 cubed is 1, over 3 is a third, 4 times 1 is 4, plus the c. Now what you should notice, and this will always be the case, is you've got the plus c and you're going to have a minus c, which means the constants will always cancel out. Remember that constant from the core 1 enabled it to find out the exact equation for the curve we originally started with. Now if we just tidy this up, this will give us our area. So 9 and 12 is 21. Add 4 is 25, 25, minus a third is 24 and 2/3. So the area underneath the curve is 24 and 2/3. Let's just do one more example so that we get the idea. So we're going to find the area under the curve of 4x cubed plus 6 between 2 and 0. So we're going to integrate that. So remember, add 1 to the power, divide by a new power. So x over 4 divided by 4 plus 6x plus the constant between 2 and 0. Next thing, right, substituting the 2. So 2 to the power of 4 divided by 4 plus 6 times 2, which is 12, plus c. Now, 0 to the power of 4 is 0, divided by 4 is 0, and 6 times 0 is 0, so we're just going to have the minus c. The two c's cancel each other out again, and we just need to sort out the other bit. So, 2 to the power of 4, well that's 16, divided by 4 is 4, plus 12, so our final answer is equal to 16. So that is a very quick example of finding the area under the curve. Now this could be applied to more difficult problems where you might be looking at a curve and the line where they intersect. You're looking for the area combined between the two. And there'll also be questions which might involve more difficult curves, original curves, things which might include shapes like this, where you're asked to find the area bound between the curve and the x-axis, which will be referring to this section here. And they are discussed in a later video.